Hello, my name is Nathan. This is my interview for the cloud operation analyst position, which big tech consulting firm. So, getting into the first question, why am I applying for this cloud position? So, the reason I want to apply for this cloud position is because I think this is the cloud computing. It is it sits at the intersection between the two things that I've been wanting to develop, which is technical cloud skills and technical problem solving skills. So throughout my learning time for cloud, I didn't just learn that I didn't just learn that all the theories around AWS. I also had a chance to transfer my basic understandings into practical projects. Um, I did things such as understanding how cloud infrastructure is priced, architectures, and all the way through security, compute storage, databases, and all the scaling. So upon learning about cloud, I've understood that cloud isn't just a technical tool, it is the operating environment that every modern business runs on. So people who can confidently operate such a ship and communicate cloud system will be valuable for corporates. Um, this role is appeals to me because it is client facing. The job description states that logical thinking, presentation skills, and project management alongside the technical requirements. It is exactly what I want to develop in my career. I don't want to just know how to work around AWS console, but also being able to explain the concept into a non-technical client about why cloud matters, what it costs, and what value it delivers. So as a fresher like me, I think this program is highly valuable, and I want a structured environment where I would be mentored and pushed to grow and challenge. And from what I understand from reading the description, I think this opportunity will offer me those um, those challenges. So moving on to the next question, what kind of instances can be created using AWS EC2? There are wide choice we can get from AWS EC2. They're organized into families based on what they're optimized for. So the first family is general purpose instances such as T3 and 6i series. They have a good mix of CPU, memory, networking, which make them great for tests like web servers, for hosting web server, small databases, and development environments. The T series specifically has something called burstable CPU performance, which means it's cost efficient for workloads that are usually 6 idle but occasionally sleep a spike of compute power. The next kind of instance is compute optimized instance, such as the C6i family. So, for example, these are optimal choice for CPU heavy tasks where raw processing speed is what matters most. And then next, we have memory optimized instances like R6i or X2 series. Um, you'll get a much higher RAM to CPU ratio, and they are ideal for in-memory databases like Redis or SAP HANA for real-time analytics workloads that need to hold large database datasets in its memory. The next kind of instance is storage optimized instance. We have some types of these such as I3 or D3. They're designed for workloads that require very high sequential read and write throughput to local storage. We can have examples such as data warehouses, Hadoop clusters, and log processing systems. And we will have also have accelerated computing instances such as P4 and G5, uh, which include GPU hardware. They are optimal for machine learning training, graphics rendering, and video processing. We also have bare metal options for workloads that need direct access and interaction to the physical hardware. High network throughput option for latency sensitive distributed applications. So it is very important for people to understand these kind of instances to make the right recommendation for according to the client's needs. For question number three, how would I set up platform on AWS EBS? So I think that uh, to clarify, CloudFront and EBS don't connect directly. EDS is not a block storage. It is attached to an EC2 instance like a hard drive. It doesn't have a public-facing endpoint, so platform cannot point to it on its own. So, however, I have worked through a project during my current learning, and in that assignment, I set up a static website running on EC2 instance, and that EC2 instance has an EDS column attached to it, storing website files. So I wanted to put platform in front of that, and then this is my steps for doing the test. I would set up this web server on the EC2 instance, which in the assignment that I worked on was Apache. So the firewalls for ADS calling are served over HTTP, and now the EC2 instance will have the public address that CloudFront can use as an origin. And then in Python, we will create a distribution, set the EC2 address as the origin, uh, configure the cache behaviors and CTL values, and add an SSL certificate through Certificate Manager for HTTPS, and hook up CloudWatch for monitoring. So to conclude, EDL itself is not a platform origin, but the EC2 instance it's attached to can be. Um, but we would have the web server in the middle of those two, and um, that is what I have done during my previous assignments, together with a lot of troubleshooting. So it was not as easy as we read in the theory. So moving on to question number four, we attended a lab with the engineering webinars and shared some key perspective that I collected after joining the webinar. Um, so the most direct connection between data engineering and cloud infrastructure is is that cloud is embedded in the data engineering. Level three of the roadmap they set is dedicated to cloud and distributed processing. It covers AWS, Azure, or Google Cloud, alongside with frameworks like Spark and orchestration tools like Airflow. So it clarifies that cloud isn't a separate discipline from data engineering or software engineering, but it is the foundational infrastructure layer that everything else runs on. The second connection I found was that around the data pipeline and services, the webinar described end-to-end pipelines, ingesting from API, transforming data, validity quality, and loading into warehouses. In a production environment, every one of those steps relies on cloud services, and such as storage will live on S3 or equivalent, compute will run on CC2 or Lambda, orchestration sits on managed services. So I think learning those AWS services in this course makes those pipeline concepts um, very easier to understand. So the third connection that I found was the reliability and ownership mindsets. The webinar gave a memorable example of a data engineering being contacted at 5 a.m. because a dashboard in Australia had failed, and he had to be able to diagnose and resolve it. That is the fundamental cloud operation requirements. When a service goes down or resource is misconfigured, the expectation is that someone take ownership, identify the root causes, and fix it. That accountability is central to the cloud operation analytical. And finally, the webinar level 4 roadmap covered monitoring CI/CD and deployment pipelines, moving from development to production, uh, managing data quality and deleting issues early. So the overall takeaway from for me was that cloud is not a standalone topic, but it is the infrastructure foundation for data engineering, software engineering, and cloud operations. Um, so that's the end of question four. So let's move to question five. This is describe and reflect my self-directed learning activity. So I have submitted my learning journey map as a supplementary material, which outlines the full 12-week progression. So here I would like to speak about the key learning shifts and what I genuinely took away from the learning process. So during the first half of the course, it was primarily about building a conceptual foundation. The module that had the most impact on me was on week 12, which was about cloud economics and building. So understanding that cloud pricing is based on how much the consumption amount is, rather than fixed amount of money. It teaches me about how I will approach architectural decisions. So I know now that every design choice carries a cost implication, and um, I would have to ask whether a resource needs to be always on and whether it can scale to zero. And this, and during the following weeks, we learned about security and networking, um, where we found out that the foundation became practical. The shared responsibility model, in particularly, shifted how I think about risk. And yes, secure the underlying infrastructure, but configuration decision, such as security groups, subnet exposure, access policy, are the operator's responsibility. And upon completing the VPC setup and configuring the web security group in WordPress assignments, um, it made it really clear for me that theory alone would not be sufficient cannot be as sufficient as having hands-on experience. So during the second half of the course, we learned about storage, databases, auto scaling, and architecture. Uh, it's this part combines all of the concept into a complete system. We have to set up S3 buckets connecting RES instance to EC2 and drawing the full system architecture diagram. So to reflect on the course as a whole, I think the most significant shift was about how I face problem with systemized thinking. So previously, I would approach an issue and focus on the immediate fix, but now I would consider the broader picture, which service is involved, what can the cost implication and the failure points, and how to communicate with trade-off clearly to a non-technical stakeholders. So that is the end of my entry. Thank you for listening.